5.3, inverse functions and relations. Everybody got on title? I got nothing to say here besides what's up next anyway, so here we go. Okay, there's a lot here. Read it all first, decipher what you need, and I'll kind of explain what you need too. We're going to do two types of problems today. Okay, one is whenever we have just inverse relationships. The other one is when we're going to do inverse functions. Okay, we're going to do inverse relationships first. So the relations are between an ordered pair set. So you have so many ordered pairs. In this example, we have 3 ordered pairs right there. Okay, and basically what it says is that two relations are inverse relations if and only if when one relation contains the element a comma b, right here, the other one contains b comma a. So between the two of them, what happened? They switched order. A goes to where A goes to the Y, B goes to the X. The way it was A was in the X spot, B was in the Y spot. That's it. So down here in the example, yes, we're going to do one like this later. If A and B are inverse relations, that means A contains the points 1, 5, 2, 6, and 3, 7. And then B is going to contain the elements 5, 1, 6, 2, 7, 3. Switch the order. Okay? Yes, that's the easy part of the day. Alright? Any questions on that? And we'll talk about the mistakes that I've seen once we get to that problem. It's not much. Okay? Your second example, if f and f negative 1, we'll talk about that later, are inverses, then f of a equals b, if and only if f to the negative first of b equals a. That's not how you actually say it, it's just how you read it. Okay? The words to properties of inverses kind of suck. Okay, the example is way better. Let's look at this. So we have one function being x minus 4. The other one is x plus 4. Alright? X minus 4 is 1. X plus 4 is a number. Hughes. It's okay. Pick a number, sir.
9.
9! Let's go in here. 9 minus 5, or 9 minus 4 is what? Whoops. 5. Put 5 over here. What's 5 plus 4? 9. What did Hughes pick? 9. What do we end with? 9. See, inverses will undo what one function does. Okay? So you undo what you've done. You invert it, right? Okay, makes sense? Alright, so that's how you know if they're inverses or not. You can see here on the example, they say let's do f of 6. They pick 6. Why 6? I don't know. But they do. 6 minus 4 gives them 2. Then they put 2 into this one with the fancy negative 1 sign, and then they do 2 plus 4 to give them 6. They started with 6. They ended with 6. There go. These two are inverses.
So the second one is just inverses.
Mm-hmm. And that's what the negative 1 part means. Okay? We'll talk more about this in the first example where we actually find these. That's what the negative 1 means, that these are inverses. Here's your original function. Here is your inverse of it. Here is the function that will undo what this one does. This is our one and only example of this one. Okay? Be ready. Find the inverse of the following set of points. If that set is 2, 3, negative 4, 8, 1, negative 3, and 5, 5. To find the inverse, take these ordered pairs and flip them into 3, 2, 8, negative 4, negative 3, 1, and 5, 5. And that is it. Okay. Okay. No, you will not have like 30 of those on your test. Sorry. Okay.
So weird.
All right. Now, yeah, you say that now, but you know what'll happen on test day? You'll do something dumb. You know what? Because I've seen it happen, okay? Whenever you just got to remember that you flip the ordered pairs themselves. And the main dumb thing I see with this is that we don't flip the ordered pairs, we just flip the signs, okay? I know I say flip a lot because you do flip a lot in here, and the only bad parts of that is between signs or numbers. What am I flipping? Here you're flipping the numbers and flipping their spots, not their signs, okay? I've seen people, bless you, flip these signs and not the numbers. I've seen people do both, flip the numbers and the signs. You just change the order of the numbers. You don't touch those numbers themselves. Okay? That's really the only thing. Some try to make it like the composing of functions like you did on your quiz. Some try to do that, which doesn't make sense to me because you only have one set. You can't do it with just one. You have to have two. So that's kind of like creative, I don't know what you're doing things, which give me laughing material, to be quite honest, because I'm like, it's not even there that you can do it, you know? So literally just flip the order. That's all you got to do, and you'll get your point. Or two. All right? Good on that one. Great, moving on. Now, obviously that's not going to be the bulk of the day, otherwise this lesson would be, pretty fairly short. What we're going to do for the most part today is instead of, let me back up just a couple. Instead of both the function and the inverse be given to us, we're going to be given this initial function and we're going to find its inverse. So this will be given to us and we need to go find this one. Okay, see how this is going to work out? The steps to do that are ahead of you in lovely white. So you can see it against the darker blue. All right. 4-step process. It's a pretty simple process, to be quite honest. It's not terribly tough. Silly mistakes can't happen, and that's where the bad part comes up. All right. But your steps are first. Number one, write as an equation with x and y. Okay, because these will be given to you in function notation. Okay, make sure you make it x and y. Do that first. Okay. Second step, switch x and y. Switch their spots. Switch their places. Where x was, y now is. Where x was, I said the x twice, didn't I? Where y was, x now is. That's step 2. Step 3, solve for y. That's where the bulk of your work's going to happen, is step 3. Okay? And whoops, my bad. And step 3, where it says solve for y, that's not necessarily just one step. Okay, that could take a few steps to get done. Okay, it could be add this over, add and multiply. It could be a plethora of things. So step 3 could be a multi-step step. And then step 4, rewrite in function notation. And we'll talk about that when we do the first one. All right, first up, find the inverse of f of x equals 2x minus 5. All right, so follow your steps. So step 1, rewrite as x's and y's. So instead of f of x, you make it y equals 2x minus 5. Okay, so step 1, done. All right. Step 2, change x and y. Flip-flop them. X equals 2y minus 5. Notice how the 2 stays on this side too, okay? You're doing no math. You're doing nothing except just rewriting it x where y was, y where x was. Okay? Step 3 is now solve for y. So before I do that, I'm going to take this guy and rewrite it so that my y is on the left. So 2y minus 5 equals x. Why do I do that? Because I like my y on the left. Because I'm eventually going to want it y equals. Do I have to do that? No, I don't. Does it help me? Yes, it does. Will it help you? Probably. All right. Now, step 3, let's start that. Step 3, solve for y. So the first step, this is where you have maybe more than one step. Okay, we got to get y what? Solve for y means get y by itself. Good. First step to do that is what? Add what?
5.
Add 5. Good. Add 5 to both sides. Gives you 2y equals x. Equals x plus 5. Are you done?
Oh, I've been hearing that train all day.
My gosh. Are you? You know, someone's going to go back and watch this video and think I'm yelling at one of you guys. Alright, next step. Divide by 2. Okay, now when you divide by 2, make sure you get it to all things. Divide by 2, divide by 2, divide by 2. Okay, it gives you y equals 1/2 x plus 5 halves. Okay, that's the end of step 3. We solved for y, we got y by itself. Alright, now there's 4 steps to this process. Step 4 is to take that and rewrite it in function notation. So f of x equals 1/2 x plus 5 halves. Now, we're vast majority correct at this point. If that was your answer and you circled that, you would miss 1/2 point. Okay? And I'll explain to you why you will miss 1/2 points. But first I want to do a little experiment and see if this works out, okay? Let's see here, Mr. Branson. Pick a number.
7.
7. Put 7 in here. What's 7 times 2? 14. 14 minus 5? 9. Good. Now take 9 down to this one. Put 9 right here. What's 9 times a half? 1/2 times 9/1. Come on. 9/2. 9 halves. Good. Okay. Now what's 9 halves plus 5 halves? How many halves do you have? Huh? 14 halves, which is 7. Did Branson pick 7? Yes. Did we end with 7? Yes. Which means these two functions are what? They're correct, but specifically inverses. Good. Now, if I said do f of 3, which one am I meaning? Do I mean this one? Or do I mean this one? Or can you not tell? This one? It's got an F. This one has an F. So if I just wrote on the board, do f of 3. This side of the room would do the top one, this side of the room would do the bottom one, and nobody would know because you guys can't read my mind, right? That's why we have to put this. Ready? -1. Okay? Because we were given this function. We found this guy's inverse. This -1 means that these two are inverses of one another. It's a notation thing. It's a symbol, basically. Okay? You will never use that -1 in the problem, but you need to put it in the answer. That way I know that these two have. Okay? That way you know that these two are different. Is it a deal breaker? No. I am picky about it, and you will lose points, but it will be a half point. Okay? So is it the end of the world if you forget? No, it's not. I'm much more interested in making sure you know how to do the math work here. But full credit includes the -1 as denoting that these two are inverses of each other. Okay?
So x is supposed to be -1.
Okay. So another one. Find the inverse of f of x equals x squared plus 1. This moves into the different situations, the different problems, the different notations that I can give you, okay, and what all I can give you. All right, this is a good example of that. But same four-step process. So step number 1, f of x goes to y. Y equals x squared plus 1. Step 2, you change x and y's places. Watch this now. X equals y squared plus 1. Even the exponent stays on the right-hand side. Literally just move the y and the x. That's it. Okay? Everybody good there? Okay, step 3, or well, not really step 3 yet, but I'm going to write it so that my y is on the left. So y squared plus 1 equals x. Now let's start step 3 solving for y. So to get y by itself, what do we do first? Come on now. Minus 1. Okay, right, 1's up there, so we subtract 1 over. So we get y squared equals x minus 1. Now, is y by itself yet? No, it's being squared. So how do we take care of this? Try again. Not divide.
No.
Square root it. Okay, you have a square power. How are you going to cancel that square power? Square root both sides. Okay, that's a little bit of a blast from the past. We'll come back to. We're going to have a bunch of those here soon. Y equals square root of x minus 1. Y by itself. Change it to function. Okay. And the nice part is you can always check yourself on these. Alright, you're always going to be able to check yourself on these. So, Miss Brown, pick a number, please. 5. 5 squared is 25. 25 plus 1, 26. Take 26 down to what you claim is your inverse. 26 minus 1 is 25. Square root of 25 is 5. Yay. Okay. Now, you guys are all picking what I'm betting is one of your favorite numbers in the world, right?
Yeah.
Okay. Mine's 7. Mine was 7. Always been 7. Soccer number's been 7 since I was like a kid. Okay. Not anymore so much, but you know, you don't play soccer when you get to be my age unless you're Mr. Schmidt and have full of energy. I'm not that full of energy, nor do I have people to go play with. So, it's 2 reasons. But anyways, I would pick a better number than what we're all picking.
26.
No.
2.
Better.
14.
Better.
1.
Better.
0.
0. Always do 0, okay? 0 squared is 0. 0 plus 1, 1. 1 minus 1, 0. Square root of 0, 0. It's going to make your life easier, okay? If we'd have done 0, well, I don't want to say that because you still... Sometimes zeros can get rid of your fractions, too, in a problem, okay? That way you don't have to worry about it, okay? Here I give you both functions. So, let's make life easy on ourselves. The directions read, determine whether each pair of functions are inverse functions. Inverse basically means undo what you've done. Invert it. Undo it. Carrie Underwood sings a song about undoing it. Okay, joke's lost, but that's alright. Let's see here. Miss Peterson. You picked a number yet? Pick a number. 10. Like it. 10. What's 10 times 3? 30. We're going to use Miss Peterson's number here. Hold on, let me write this down because I want to show the work that we want to show. Okay? The number is 10. That's what we're focused on. 3. 10. Plus 9. 3 times 10. 30. 30 plus 9. 39. Take 39 over to here. 1/3. 39 minus 3. Okay. 1/3 times 39. 39 divided by 3.
7.
Nope. 13. 13 minus 3 gives us 10. Did we start with 10? Yes. Did we finish with 10? Yes. What are these? They're inverses. That's all you got to check, okay?
What if they don't give you a number?
Well, Booker, I guess we're going to probably do that next, huh?
Oh, my fault.
It's okay. As they say on a certain radio show, you're mowing my lawn, buddy. Okay? We'll get to one like that, all right? But if you do your order of operations right, you put them, plug them in where they're supposed to go, and you get the same number that you started with, you're golden. They're inverses, okay? And this number up here can be whatever number your little heart's desire. 10, 20, 2, 5, -7. Let's try not doing negative numbers, okay? Let's try to keep it basic. 1, 2, 3, something like that, okay? And then if that's what you end up with, great, we're good. All right? Questions on this?
0.
I love 0.
You said we can choose.
You can choose whatever number you like. So, Mr. LaFleur, pick a number. Not 0. Let's go crazy. Let's go 100. Awesome. I like it. Nope, too bad. 100. 100. Here we go. 4. 100 squared. What's 100 times 100? 1,000. 10,000. 10,000. All right? Yeah. 1, 2, 3, 4 zeros. 1, 2, 3, 4. There we go. Okay, so we're at 10,000. See, Mr. LaFleur, look what you're doing to us. 4 times 10,000. 40,000. 40,000. Yeah, boy. So now, got to take that up here. So 2 square root of 40,000. Someone with the calculator. What's the square root of 40,000? Hmm? 200. Bet you didn't know that, huh? What's 200 times 2? 400. Okay. Mr. LaFleur, what do we start with? 100, and the class thanks you for that, by the way. What do we finish with? 400. Are they inverses?
Not at all.
No.
See, I told you it's wrong. I was just playing over 100.
That's okay. We can play along. It's no big deal. Because guess what would have happened? No matter what number he picked, these weren't going to end up being the same.
Why was it like that?
It's just the way it's set up. I can just, I could just easily take one and change one number, and then boom, they're inverses, or boom, they're not.
Right.
So it's just the way it's set up, yeah. Okay? So are these inverses? Not.
Not at all. Not at all.
Not inverses. No, something like that, okay? Now, here's the good news for you guys. You could theoretically do this problem this way, make a mistake, and still answer the question correctly.
How is that possible?
Okay? Yeah, exactly. Okay, so you guys are in kind of good shape. Think about this. Let's say instead of, when we went from square root of 40,000 to making it 200, let's go ahead and say we accidentally made it 2,000, right? 2,000 times 2 is 4,000, right? 4,000 still ain't 100, so even though we made a boo-boo here, we still don't have 100 as our answer, so we're still going to answer the question, not inverses. See what I'm saying?
Yep.
So you guys do have a little bit of freedom to the point that you might be able to get by with making a boo-boo and still being all right. Because on the question like this, since you all pick different numbers probably, chances are I'm not going to look a whole lot at your work. I want to make sure you know that concept. I will get you on the ones that should be inverses though, obviously. Okay? But the few and far between that aren't,
So how was it set up to make it not be an inverse?
you can you'll be able to start. Everybody good up here? Okay. you'll see a pattern, kind of. The more you do them, you'll start seeing a pattern with the numbers, the ones that are inverses. Like this one has 3 and 9 and a plus, a third, minus, and 3. It's you can kind of see a pattern of how it would work, you
The
know.
other one's a square root.
Right, and you would think this one would be. If this was a fourth here and not 2, then they would be. Okay. This one's not. Okay, because if you look at the minus 3 here and the plus 4 over here, you can see kind of how that's going to mess up your number, so it's not going to work out. So you can kind of see a pattern once you practice them, as far as what works and what don't. Okay, I want you guys to try that one out real quick. Last one. All right. Okay, one like this, honestly, I would pick 0, 1, something small, something like that. Okay, just make sure, and you can go. And the fun part is well, I don't want to say fun, I guess, because you might get a little nasty. But typically the way these problems are set up, you should probably go in the order that they're given. Go into F and not into G, okay? You could technically do it either way, but if you put, let's say, 0 here. 0 plus 1, 1/2. Square root of 1/2 is ugly, okay? And then you have to go square. Could you do it? Yes, you could. It's a little nasty, though, okay? So put 0 in here is 2 times 0 squared minus 1. 0 squared is 0. 2 times 0 is 0. 0 minus 1, negative 1. Okay? John? Sure. Square root of negative 1 plus 1 over here. Divide that by 2. Negative 1 plus 1 is 0. Divide by 2, 0 over 2 is 0, and the square root of 0, 0. Are they inverses? Yes. Page 333, 11 through 23. This is due tomorrow. You have a lesson check over this tomorrow. All right? Don't forget about it.